Greetings from the sub-ether. This is Alan with another quick extended color basic video, continuing my exploration of the high-resolution graphic screens on the color computer. I wanted to find out how much memory was actually being taken by an object that you draw on the screen, because in extended basic it scales everything. So you might think you're drawing a 32 by 32 box, but the actual number of pixels it draws is scaled based on the graphics mode that you're using. So I created a spreadsheet. On the first line are all the different P modes, 0 through 4, 5 different graphics modes. I put in the width and height of each mode. P modes 0 and 1 are 128 by 96. P modes 2 and 3 is 128 by 192. And P mode 4 is 256 by 192. I then wanted to put the colors that each one takes. You'll notice that P mode 0, 2, and 4 are all the two color modes, black and white. P modes 1 and 3 are the 4 color modes. Then I needed to type in how many bits per pixel that was. So I know that if I'm in a 2 color mode, each pixel is a bit, therefore there are 8 pixels per byte. On a 2 color mode, each pixel takes up 2 bits, therefore there are 4 pixels per byte. And there's the same pattern, 0, 2, and 4 are 8 pixels per byte. P mode 1 and 3 are 4 pixels per byte. Then the memory and how many pixels it was, which I'm not using for anything. Now in this graphics mode on the color computer, no matter what mode I'm in, I draw based on the maximum resolution of 256 by 192, and Extended Basic scales that to the actual screen. Which means if I draw a box that fits the entire screen 256 by 192, that will actually draw a box 128 by 96 for P mode 0 or 1, or 128 by 192 for P modes 2 and 3. So the actual width and height, the way I determined what to do with that is I noticed that the width is 128 on every graphics mode except for 4. So if my P mode is less than 4, simply divide the width by 2. So that's what I did with the actual width. I just had a little formula that says if the P mode line is less than 4, divide the width by 2. So when it gets to P mode 4, that's not less than 4, it leaves it alone. It's 32. All the rest of them, the actual width will be 16. For the height, I noticed that P mode 0 and 1 were 96, 2, 3, and 4 were 192. So if the mode was less than 2, divide the height by 2. And that's the formula I put here. Therefore, the column in 0 and 1 get divided by 2. Everything else becomes normal, 32. Then I can calculate the actual number of pixels by multiplying the actual width and height, and I get that. Then I want to turn that to bytes. Well, that's where it gets tricky, because 16 by 16 is 256 pixels. But a pixel might be 1 bit or 2 bits. So the way I determined that is I know that I start with black and white modes where there's 8 pixels per bit. And if it's one of these other modes with 2 colors, it's going to be 4. So I want to start with 8 and either divide that by 2 or subtract 4. Either way, I just chose to subtract 4. And I did that by ANDing the mode number with the number 1. If you AND an even number with 1, you get 1. So if I AND P mode 3 or P mode 4 with 1, I will get back 1. If I AND an even number like 0, 2, or 4 with 1, I get back 0. So my formula for the bytes was simply, I'm going to take the 8 minus the mode and 1 times 4. So if the mode is 0, it will be 8 minus 0 times 4, which is 0. So it's just 8. So I can take pixels divided by 8. That's 32. Over here, it's going to take pixels minus 8 minus 4 times mode and 1. Well, mode 1 and 1 is 1. 4 times 1 is 4, so it's 8 minus 4. That's 4. So it's 256 divided by 4. And that gives me 64 bytes. And so that's basically my formula I use to calculate how many actual bytes this 256 pixels is going to take. In the mode where it's just 2 colors, black and white, I can fit 8 per byte. In the 2 color modes, I can fit 4 per byte, so it takes twice as much memory, and that's what you see as we progress up the resolutions. Then to get the number of elements in an array it will take, which is something for the get and put videos, I simply divided the number of bytes by 5, added 0.5 to it to round it up, turned it into an integer, and then to know how much is going to be put in the dimension, I just subtracted 1 because dimension starts at 0. So if I want 6 elements, I would dimension the variable to 5. That gives me 0 through 5. That's 6. Let's look at how this works. Actually, in BASIC, I wrote this program that recreates the spreadsheet. I can type how big my object is that I want to draw on the screen, like a 32 by 32 box. It shows the different PMODEs and what their resolutions and colors are. Then it tells me for mode 0, 32 by 32 is really a 16 by 16, which is 256 pixels. That would take 32 bytes of memory and 6 array elements. For PMODE 1, that's the same resolution, so 32 by 32 turns into 16 by 16, 256 pixels, but because it's a 2-color mode, the pixel data takes twice as much memory, so it's 64 bytes. And so on with PMODE 2, 3, and 4. You'll notice that PMODE 4 is left alone. 32 by 32 is 32 by 32. Multiply that out, get 1024, and divide that by 8, because there's 8 pixels per byte, you get 26. So the bottom 2 modes, 3 and 4, use the same amount of memory, and PMODEs 1 and 2 use the same amount of memory, and PMODE 0 is that weird one that is the lowest resolution with only a single color. Well, 2 colors, black and white. So this is the program that I came up with to do this. I could run that and type in a different value like 20 by 20, and it'll calculate that as well. These are going to be the numbers that are going to be used for calculating how much memory the get command needs when I want to grab something off of a graphic screen and put it somewhere else and kind of play with the software sprites. So once we implement this in the get and put routines in a future video, I'm going to show you the next problem that I ran into doing this. But it was interesting seeing how much memory is actually taken by a 32 by 32 box on the screen. It's different. Depends on the graphics mode, because BASIC is always pretending it to be 32 by 32. And here is this program. Whoops. Here is this program. The code that is in here is very similar. I start with my width and height. W and H is width and height. If the PMODE is less than 4, divide the width by 2. If the PMODE is less than 2, then divide the height by 2. Pixels equals width times height. The number of bytes is pixels divided by 8 minus 4 times mode and 1, which will either be a 0 or a 1 based on the mode. So that'll either be an 8 or an 8 minus 4. Then the number of elements is simply bytes divided by 5 plus 0.5, and I use int to round off the decimal points. Not really necessary. By the time you pass it into the dimension command, it does that for you. And just printing them out. So there we go. There's my little program that converted the spreadsheet math into BASIC. I'll be back with another video where I plug this into my get and put sample code, and we will continue on with get and put. Until next time, don't panic.